It's been a while since we thought about arithmetic sequences, so I want to remember what these are. Remember, this is where we would start off at a number and pick a favorite number. Let's say we start off at 8, and then we would start adding this common difference d. So let's say that my common difference is a 3, so I'm going to start adding 3, plus 3, plus 3, plus 3, plus 3, and so on. All right, and what we want to do in this video is come up with a shortcut formula for finding the nth partial sum. So let's say I take these numbers that I've got listed here. I've got 6 of them. Let's say we want to find the 6th partial sum. Okay, so this would be adding up 8 plus 11 plus 14 plus 17 plus 20 plus 23. This one is not that big. I could just plug that into my calculator or even add it by hand, and we could come up with the answer pretty easily. But what if I asked you to find S sub 100 or 150? Is there an easy way to just plug into a formula and come up with the nth partial sum? It turns out that there is, but we have to think about these sequences in a very particular way to do that. So instead of thinking about this sequence as adding 3 to each term, we're going to think about it this way. We're going to say, well, we added 3 to get here, and then we added 6 to get here. So going from the first term, we're adding multiples of that common difference. So add the common difference, add 2 times the common difference, add 3 times the common difference. We're also going to think about going from the right-hand side of this partial sum backwards. All right, so this is our a sub n, our last term, our a sub 6. And if we go backwards, I would be subtracting that common difference. So I'd subtract the common difference, and I'd subtract 2 times the common difference. So we're going to think about this sequence this way, whether there's 6 terms or 600 terms, we're going to think about adding common differences from the front and subtracting common differences from the end. All right, here is in symbols what I was writing out in numbers on the last slide. So let me remind you of what that was. We had a sequence that was 8, and then the second term was 8 plus the common difference. The third term was 14. That was 8 plus 2 times that common difference. That was 6. And then I said we were also going to think about it backwards. So our last term in our partial sum was 23. And we said we would think about this going right to left as 23 minus our common difference, and then 23 minus 2 times our common difference. And then this formula kind of allows for there to be lots of terms in the middle. So we could do this for 6 terms, or we could do it for 600 terms, and it wouldn't really matter. Now I'm going to do something very strange. I'm going to write this whole sum backwards. All right, so this is the same formula. I'm just going to copy it in mirror image. So I'm going to start off with a sub n and write it backwards. The next term would be a sub n minus d, a sub n minus 2d, and then possibly a bunch of terms in the middle. And again, I'm just mirror imaging this. So I'm going to write, going right to left, a sub 1 plus 2d, a sub 1 plus d, and a sub 1. All right, that looks completely weird. Why in the world would I do that? This is going to get us to a formula for s sub n. This is going to eliminate this dot, dot, dot business in the middle. All right, so now I'm going to add together these 2 equations. Big, long addition bar. If I add on the left, I'm going to get 2 times whatever this partial sum is. And I've got s sub n plus s sub n. And that's really what we're looking for as a formula for s sub n. So I've got 2 times that. And then look at what happens at each pair of terms that I've lined up here. I've got a sub 1 plus a sub n. That's from the first green box. And then my second 2 terms, when I add those together, the 2 common differences are going to cancel out. And I've got a sub 1 plus a sub n again. And look, that's going to happen over and over and over again. If I draw these boxes, all of the common difference stuff are going to cancel out all along the way. And every pair of terms is going to collapse down into a sub 1 plus a sub n. All right, so this is going to happen for all these dot, dot, dot terms in the middle, whether there's no terms there or 600 terms there, you're going to get a sub 1 plus a sub n for every green box that you do. All right, so let's keep track of these. Okay, so 1 green bracket for every green box. All right, so how many of those a sub 1 plus a sub n terms do I have? Well, just count by subscripts, a1 all the way to an. I've got, if that's a1 all the way to a50, I've got 50 of them. It's just n of them, whatever n happens to be. So 2 times s sub n is going to equal to n copies of a sub 1 plus a sub n. That is a formula that doesn't have a dot, dot, dot in the middle of it. So I'm going to divide both sides by 2. And we get our formula for the nth partial sum of an arithmetic sequence, n times a sub 1 plus a sub n divided by 2. I told you it was going to be a lot of symbols on this slide. All right, but that's the punchline. This is the formula that we need, and now you know where it came from. We'll do a couple of examples with this in the next video.